Hello viewers, welcome back to another section of my multivariable calculus tutorials. In this tutorial class, we're going to solve a problem in finding the surface area of quadric surfaces. Now, I have a problem here. It said, find the surface area of the portion of the surface z is equal to the square root of 4 minus x squared that lies above the rectangle R in the xy plane whose coordinates satisfy 0 times 1, 0, 1 times 0, 4. If this is the first time you are visiting this channel, you don't forget to subscribe and you turn on your notification button so that you get notified when I post new tutorials. Let's go straight to what you have for this video, and don't forget to watch the video to the end so you understand every portion of the video. So right now we want to find the surface area of this region here over a particular boundaries. So the surface area is actually found. You want to find S is taken by the square root of fx squared plus fy squared then plus 1. That is, you take the square root of the partial derivative, the square of the partial derivatives, then you sum them plus 1, then you integrate this expression. So our s will be equal to double integral of this expression, square root of fx squared plus fy squared plus 1, then the a over the region we want to integrate. So let's see. I have my function z, which is same as f of xy. That is, it's a function of x and y. But in this particular question, we don't have y. Our y is 0. But looking at our boundaries, it should tell you that we have y limits. So y is included in our function. And it's equal to square root of 4 minus x squared. Right. So once you have this, what you're going to do is you are going to find our fx and fy separately. And after you come and put it in this formula. So our fx is simply equal to taking this a composite function from our knowledge in calculus 2. This is the same as 4 minus x squared all to the power half. I'll first differentiate what I have inside. That is going to give me negative 2x. And after, it's going to multiply the derivative of the whole thing. That is half multiplying 4 minus x squared to the power negative half. So once I have this, I just expand this and I'm going to have my 2 cancelling these 2. So my fx is simply equal to negative x over the square root of 4 minus x squared. What about fy? Our fy is 0 because the y term here is assumed to be 1. So 0. Then quickly we move to our integral and you realize that our integral becomes the integral of the square root of 0 squared, the fy squared plus negative x all over square root of 4 minus x squared all squared plus 1. Then I don't want to introduce the limits now. Let's further simplify, then I introduce the limits. So at this point we have to simplify what I have here. So I'll get the square root. This will give me x squared over 4 minus x squared then plus 1. Here is negative, right? Yep. So when I simplify this, I'm going to get, I'll multiply 1 by this whole thing here. So I'll get negative x squared plus 4 minus x squared all over 4 minus x squared here. So let's see. Sorry, this is going to be positive after we have squared, so the negative will go away. So Here becomes x squared plus 4 minus x squared all over 4 minus x squared. So at this point, this x squared will cancel this out, and we are going to be left with what? 4 over the expression 4 minus x squared. So this simplifies to 2 over the square root of 4 minus what? X squared. So this is what you've got now, and you have to introduce our integral sign and all that. So I have integral. My inner, I have 2 over 4 minus x squared here. Then I'm going to integrate this with respect to what? X fixed. Then I come to respect to what? Y. Any of them is going to give us an answer. So let's see. My endpoint, I have the x to be 0, 1. So with this, I have the x to be 0, 1, and I have the y to be what? 0, 4. Like this. So once I have this, I'm simply going to integrate with respect to the x, then the y, as I have here. So with this, how do I get the integral of this? So this is integral 0 to what? 4. Then our inner integral, this becomes the derivative of inverse trig functions. So I'll have 2 out, then integral 0 to 1 of 1 over root of 4 minus x squared dx dy. And you realize that if you have the 1 over square root of a squared minus x squared, that is going to give us sine inverse of what? X over a from the derivative of inverse trig functions. So at this point, my derivative simply simplifies to the 2 sine inverse of what? X over 2. So this becomes 2 squared from 0 to 1, then dy, like this. So once I have this, I move on to my simplification, and I'm going to get 0 to 4, 2 sine x. So I'm going to put 1 here, then I'll put 0. So when I put 1, I'm going to get 2 sine what? 2 sine inverse of half. Now when I put 0, sine inverse of 0 is 0, so I'm going to do away with that. So dy. So this becomes 0 to 4. Sine inverse of what? Half is 30, which is what? Pi on what? 6, right? So 2 multiplying pi on 6 dy. Then finally, I'm going to get 0 to 4. 2 is going to cancel 6. I'll get pi on 3 dy. And I integrate with respect to what? Y. So I'm going to get pi on 3y, 0 to 4. So I'll put 4 there, then I'll put 0. I'm going to get 4 pi on 3 minus 0 multiplying pi on 3. And that is finally giving me 4 pi on 3. So this is the surface area of the quadric surface given over the region 0, 1 times 0, 4. Thank you for watching this video. Don't forget to like and subscribe.